And welcome to Maths Atoka online class. In today's video, we'll be solving these simple questions in Math 111, Algebra and Trigonometry. Okay. The first question said, find the equation whose roots are given below. Okay. If you have not watched my video on roots of a quadratic equation, okay, you can go and watch it. Let's solve this question. But if today is the first day of watching our video, please subscribe. Okay, and then turn the notification bell so that YouTube will notify you each time we drop a video. Okay, so let's do that. Before you find the equation, okay, any quadratic equation, the formula is simply x squared minus sum of roots. We now put x plus what? Product of roots equal to 0. Okay, as simple as that. So we need the sum and the product, then we are good to go. So the first thing you get is what? The sum, and the sum is simply to add. So for the first one, for a the sum is what? Minus 3 over 5. These are the roots, so the sum means to add it, plus what? 4, which will give you the LCM is what? 5. So 5 divided by 5, 1 times this, minus 3, plus 5 divided by this, 5 times this, 20. So both of them is giving me 17 over 5. This is the sum. Now the product is simply to multiply both of them. Minus 3 over 5 times 4 over 1. This time this will give you minus 12 all over what? 5. Okay, so since I have gotten the sum and the product, my equation is now x squared minus sum, you put what? X plus what? Product is equal to 0. So let us substitute. I'm having x squared minus, what is my sum? My sum is 17 over 5. I'll put x plus the product. The product is minus 12 over 5. Okay, is equal to 0. So the denominator, to remove the denominator is to multiply each term by the LCM of the denominator, and the LCM of this is 5. So we say multiply by 5. Multiply by the what? LCM, which is what? 5. We are multiplying by 5. So I have 5 times this, 5x squared. 5 minus 5 times this one will give you the 5 will cancel the, or let me just make you understand by saying 5 in bracket of x squared minus 5 in bracket of 17 over 5x. Okay, minus plus is minus, so I'm having minus 5 in bracket of 12 over 5. Okay, is equal to 5 in bracket of 0. Okay, so this time this is giving me 5x squared. 5 will take care of 5, so I'm having minus 17x. 5 will take care of 5, I'm having minus 12 is equal to what? Anything times 0 is 0. So this is the required equation for number 1. So for A, so let's go to B. Now for B, the same thing is applicable for B. So we get the sum. The sum simply means to add. That is 5 plus minus 4, which is what? 5 minus 4, which is what? 1. This is the sum. Now the product is what? 5 times that minus 4, which is what? Minus 20. So my formula is simply x squared minus sum, you put what? X plus what? Product is equal to 0. So what do I have now? X squared minus, we have gotten our sum to be 1. X plus what? Product, which is what? Minus 20 is equal to 0. So 1 times x is same as x. So I'm having x squared minus x minus 20 is equal to 0. So this is the required equation for that. So let's move to the next one. Question number C. This is B. So for question number C said sum, the same thing. The sum means just to add these two, which is what? 11 over 4 plus 3 over 2. So the LCM is 4. 4 divided by 4, 1. 1 times 11. 11 plus 4 divided by 2 is 2. 2 times 3 is 6. So I'm having what? 17 over 4. Okay? Now product means to multiply them, which is what? 11 over 4 times 3 over 2, which is what? 3 times 11, 33. All over 2 times is 8. Okay, so I've forgotten the sum and the product. So my equation is now what? x squared minus sum, I'll put what? X plus what? Product is equal to 0. So what do we have now? We're having what? X squared minus, what is the sum? The sum is what? 17 over 4. I'll put my x plus the product is what? 33 over what? 33 over 8 is equal to 0. So let's multiply everybody by the LCM. And the LCM of 4 and 8 is 8. So we are multiplying by 8. Multiply each by 8. So we have what? 8 in bracket of x squared minus 8 in bracket of 17 over 4x plus 8 in bracket of 33 over 8 is equal to 8 in bracket of 0. So this time this I have what? 8x squared. This take care of this is 2. 2 times this is 34. So minus 34x. 8 take care of 8 plus what? 33 is equal to this time this 0. So this is the required equation for that number C. So let's go to number D. So D said the sum means to add, which is what? Sum is equal to minus 3 plus minus 10. Okay, which is minus 3 minus 10, which is what? Minus 13. Then product means to multiply, which is minus 3 times minus 10, which is what? Minus minus plus 3 times this 30. So I've gotten my sum and the product. My equation is simply x squared minus sum. You put what? X plus what? Product is equal to 0. So what do you do now? You have what? X squared minus, what is the sum? The sum is giving me minus 13. I'll put x plus the product is 30 is equal to 0. Minus minus is plus. So I'm having x squared plus 13x plus 30 is equal to 0. As simple as that. So the next one is E. So E said minus 2 twice, which is what? The sum is now minus 2 plus another minus 2 because it's minus 2 twice, which is what? Minus 2 minus 2, which is minus 4. So the product is simply what? Minus 2 times minus 2. Minus minus plus 2 times 2, 4. So what do we have now? We're having that the equation is x squared minus sum. You put what? X plus what? Product is equal to 0. So what do we have now? X squared minus, the sum gave us minus 4, put x, plus the product gave us 4 equal to 0. So which is what? X squared minus minus is what? Plus 4x plus what? 4 is equal to 0. So this is the required equation. So let's go to the next one. It's the same method we have been using all this while. So that's why I'm rushing it. So I have the next one is sum. Sum again. Sum is what? To add them, which is what? 0 plus 6, which is what? 6. And product is simply to multiply, which is what? 0 times 6, which is what? 0. And the equation said x squared minus sum. You put what? X plus what? Product is equal to 0. So what do we have? X squared minus, the sum gave us 6x plus the product gave us 0 is equal to 0. So anything plus 0 is still the same thing. So the answer is simply x squared minus 6x is equal to 0. So that is that. So the next one, F. Okay, G said they gave us 7 plus or minus this. Okay, so the roots are 7 plus 2 root 2 over root 3 over 2, or 7 minus 2 root 3 over 2. Okay, so this is the roots. So let's get the sum. The sum is simply 7 plus 2 root 3 over 2 plus 7 minus 2 root 3 over 2. Okay, so if you look at that, you see that the LCM there is 2. So I'm having 2 divided by 2, 1 times this is 7 plus 2 root 2 plus this divided by this 1 times this is what? 7 minus 2 root 2. So what do we have now? We're having that root 3, not root 3. So I'm having minus 2 root 3 plus 2 root 3. This and this will give me 0. Okay, so I'm left with 7 plus 7, 14. 14 divided by 2 will give you what? 7. That is the sum. Now what about the product? the product is simply 7 plus 2 root 3 all over 2 times 7 minus 2 root 3 all over 2. Okay, so what do you have? This time this will give me 4 in the denominator. Now the numerator is difference of 2 square, but if you don't know that it's difference of 2 square, just say 7 times everything here, this one times everything, or let's do it like that so that you understand. 7 times 7, 49. 7 times this will give you minus 14 root 3. Okay, this time this will still give you plus 14 root 3. Then 2 times 2, that is minus 4. Root 3 times root 3 is just 3. Root 3 times root 3 is 3. Now this one in the denominator is gone, so I'm left with 49 minus 12 divided by 4, which will give you what? So I'm having 49 minus 12, so I'm having 37 over 4. 37 over 4. Okay, so this is the sum and the product. So what do we do now? Let us get the equation. Okay, we have gotten that the sum is 7 and the product is 37 over 4. So permit me to clean here so that we can get the required equation. Okay, so the required equation said x squared minus sum, you put what? X plus what? Product is equal to 0. So I'm having what? X squared minus 7, you put your x, plus 37 over 4 is equal to 0. So multiply everybody by 4 so that the denominator can disappear. So multiply by 4 to have what? 4 in bracket of x squared minus 4 in bracket of 7x plus 4 in bracket of 37 over 4 is equal to 4 in bracket of 0. So this time this 4x squared minus 28x, this will take care of this to have plus what? 37 is equal to 0. So this is the required equation. So the next one, H said that the equation is what? 3 plus root 11, or sorry, the roots are 3 plus root 11 or 3 minus root 11. The same method, the sum is simply what? To add them, which is what? 3 plus root 11 plus 3 minus root 11. Root 11 minus root 11 gone. 3 plus 3, 6. So the product simply means we should multiply them, which is what? 3 plus root 11 times 3 minus root 11. Okay, so this is difference of 2 square, or you can just do that 3 will multiply everything and this one multiply everything, but I know that it's difference of 2 square, so which is what? 3 squared minus root 11 squared, which will give you 9 minus 11, which will give you minus 2, right? Minus 2. So I've gotten the sum and the product. So what do we do now? That the equation is now x squared minus sum, you put what? X plus what? Product is equal to 0. So what do we have now? We now have x squared minus, the sum is what? 6, you put your x, plus product is now what? Minus 2 is equal to 0. So I'm having x squared minus 6x minus 2 is equal to 0. So that is the required equation. Okay, so the last but not the least is I. The last but not the least is I, and I said the sum is simply to add 7 plus 4, which is what? 11. Okay, then the product is what? 7 times 4, which is what? I think 28. Okay, so now to get the sum and the product, so I'm having the equation is now what? X squared minus sum, you put what? X plus product is equal to 0. So I'm having what? X squared minus the sum is what? 11, you put x, plus the product is what? 28 is equal to what? 0. That is the required equation. So let's go over to number 2. For number 2a, they gave us the equation that said x squared minus 8x minus 12 is equal to 0. Now to get the sum, the formula said, in fact the the general quadratic equation, which is ax squared plus bx plus c is equal to 0. And the one they gave us for a, this is general one. For a, they gave me what? X squared minus 8x minus 12 is equal to 0. And which, if I compare this, I'll see that a is equal to, nothing is standing here, which is 1. And b is equal to what? Minus 8. And c is equal to what? Minus 12. So to get your sum means it has a formula that says minus b over a, which is what? Minus this one. Then my b is minus 8. Then over a is what? 1. So which will give me just 8. Okay? So product, the formula is what? C over a, which is what? Minus 12 over 1, which is minus 12. Okay? So, and that is what they say we should find. We should just find the sum and the product. I have gotten for a. So for b, they gave me 4x squared minus 2x minus 9 equal to 0, which shows that a is 4, b is minus 2, and c is what? Minus 9. So therefore the sum has a formula. We said minus b over a, which is what? Minus into minus 2 over my a is 4, which is what? 2 over 4, which is 1 over 2. That is my sum. Then the product has a formula, which is c over a, which is what? Minus 9 over 4, and that is that. So I've gotten the sum and the product for a and b. So let's go to c and d. So for c they gave me 2x squared minus 5x minus 8 is 0. So we say that a is 2, b is minus 5, and c is what? Minus 8. So as simple as that. My sum is simply minus b over a, which is what? Minus into minus 5 all over what? 2, which is what? 5 over 2. So the product is simply c over a, which is what? Minus 8 over 2, which is minus 4. As simple as that. So let's go to the next one. A, B, C, D. Let's go to D. And this said that what? 3x squared plus 4 is equal to 6x. In fact, you have to arrange it to be in this form, and it must be equal to 0. So we need to take this one back to this side. So I'm having what? 3x squared minus 6x plus 4 is equal to 0. So that we can compare it with this. So therefore, my a is 3, my b is minus 6, and my c is 4. So the sum has a formula. We said minus b over a, which is what? Minus into minus 6 over 3, which is what? 6 over 3, which is what? 2. Okay? So the next one is product, and the product is what? C over a, which is what? Minus 4 over what? Over 3. Is it minus 4? Sorry, C over a, which is just 4 over 3. 4 over 3. And that's all. So let's go to the next one, E and F. E and F. For E, they gave me that 5x squared plus 2x is equal to 10. So it must be in this type of equation, equal to 0. So we have to bring this one to this side to have 5x squared plus 2x minus 10 is equal to 0. Automatically my a is 5, my b is 2, and my c is minus 10. So the sum is simply minus b over a, which is what? Minus 2 over 5. And then the product is simply c over a, which is what? Minus 10 over 5, which is minus 2. Okay? Then for f they gave me that what? 3x plus 1 is equal to what? X squared. In fact, we are going to take everybody to this side and equate to 0. So I'm having that 0 here is equal to x squared. This one coming here minus 3x. This one coming here minus 1. So I can rewrite it to be x squared minus 3x minus 1 is equal to 0. Okay? So which shows that my a is 1, my b is minus 3, and my c is minus 1. Okay? So that is that. You can decide to bring this one here, you will still get the same answer. So my sum is what? Minus b over a, which is what? Minus into minus 3 over what? 1, which is what? Plus 3. And my product is simply c over a, which is what? My c is what? Minus 1 over 1, which is minus 1. So I have gotten that. Let's move over to G and H. G and H. So for G and H, G said x squared minus 5 over 7 is equal to 0. Okay, I can decide to multiply everybody by 7 so that the denominator can disappear. So I have 7x squared minus 5 is equal to 0. Okay, now if I want to arrange it to be in this form, I will have that my x is what? Sorry, my a is 7. There is no b because there is no x squared, so my b will turn to 0. Okay, and then my c will now be minus 5. Okay, so this thing means that my sum has minus b over a, which is minus 0 over 7. 0 divided by 7 is 0. Okay, so the next one is product. Product is what? C over a, which is what? Minus 5 over 7. As simple as that. Okay, so the next one is H, and H said x squared plus 3x is equal to 0. As simple as that. It shows that my a is 1, my b is 3, I don't have my c, so my c will be 0. Okay, so the sum is simply minus b over a, which is what? Minus 3 over 1, which is minus 3. But the product is simply c over a, which is what? 0 over 1, which is 0. 0 divided by anything is 0. Okay, so the next one, the last but not the least, is H, I, and J. I said they gave me x squared minus x plus 1 equal to 0. So my a is 1, my b is minus 1, and my c is 1. So the sum is simply minus b over a, which is what? Minus before minus 1 over 1, which is 1 over 1, which is 1. So the product is c over a, which is what? 1 divided by 1, which is 1. So the last one, which is ij, j said 2x squared minus 3x minus 2 equal to 0. As simple as that. My a is 2, my b is minus 3, and my c is minus 2. Okay, so if you do that, you are going to have that the sum is simply minus b over a, which is what? Minus into minus 3 over 2, which is 3 over 2. Okay, so the next one is the product. The product is c over a, which is what? Minus 2 over 2, which is minus 1. So that is that for this one. So let's move over to the next question. Okay, let's move over to the next question. Okay, this question said, they said from the following, find absolute value of z and argument of z. Okay, if a question said that z is equal to 3 plus 2 root 3i, okay, and b question said that z is equal to 2 plus 2i, okay. C question said that z is equal to just I. D question said that z is equal to minus 4, and then A, B, C, D, E question said z is equal to 1 minus I. C, D, E, F question now says z is equal to root 3 minus I. Okay, solution. Now, for A they said that what? Z is equal to what? In fact, the normal formula is what? X plus yi, okay? Which is what they gave us as what? 3 plus what? 2 root 3i. So automatically, our x is 3. From here, our x is equal to what? 3. Okay? Our x is the one that does not have I, which is called the real part. Then my y is now the one that has I, which is the imaginary part, which is what? 2 root 3. Okay? Absolute value of z is called the modulus of z, which is the square root of x squared plus y squared, which is what? The square root of 3 squared plus 2 root 3 all squared. So I'm having the square root of 9 plus 2 squared is 4, 3 squared, so that is 4 bracket, root 3 squared is just 3. So I'm having the square root of 9 plus 12, which is what? The square root of 21. Okay, so that is that for what? For the modulus. Now for the argument, to get the argument, first of all you need to draw it. Let us draw it. If you draw it like this, my x is positive. This is positive x, negative y, positive y, negative x. Okay, so my x is positive, draw line on the positive x. My y is still positive, draw line on the positive y. Now trace both of them to meet. Okay, they met at the first quadrant. So since they met at the first quadrant, your answer must fall within that first quadrant. So we know that to get our argument of z is known as theta, and is equal to what? The tan inverse of the absolute value of what? Y over x. Okay, so our theta is now tan inverse of absolute value of my y is 2 root 3 divided by what? By 2, by 3. Sorry, my z is 3. So you get that. So divide this, then find the tan inverse. So let's divide first. I'm having 2 okay, so I'm having 2 root 3 divided by 2 I'm having 2 times root 3 divided by 2 times root 3 divided by 3. You get equal to. So tan inverse of that answer change from radian to degree. Sorry, I'm having, let me do it again. In fact, use your calculator and do it, please. Just do 2 root this. I don't have a good calculator. 2 root this divided by 3. Then do tan inverse of that, your answer. You get your modulus. Okay. So the next one, number B. In fact, the answer you are going to get must fall in the first quadrant. Okay. It must fall in the first quadrant because they are all positive. So let's look at the next one. Number B. Number B said that z is equal to what? 2 plus what? 2i. Okay. The modulus z is equal to what? The square root of x squared plus y squared. And this is my x, this is my y, which is what? The square root of 2 squared plus 2 squared, which is the square root of what? 4 plus 4, which is what? The square root of 8. And square root of 8 means 2 root 2, if you want to break it down, or you leave it like that. Okay? So the next one is the argument. Argument of z is taken as theta, which is what? The tan inverse of the absolute value of what? Y over what? X. But I have to draw it. Positive is still in the first quadrant again. Okay, so I'm going to have the tan inverse of 2 over 2, which is what? The tan inverse of 1. And tan inverse of 1, tan 45 is 1. So tan inverse of 1 is 45. So I have 45 degrees. See, 45 degrees is in the first quadrant. So that is my answer. So let me go to the next one, C. The next one, C said that z is equal to what? 0 plus I. Okay, let me have the x and my y. That's why I added 0 plus I. So which means that my x is 0, while my I is what? It's not 0, but the coefficient here, and the coefficient here is 1. Okay, so my modulus is simply the square root of x squared plus y squared, which is what? The square root of 0 squared plus 1 squared, which is what? The square root of 1, which is 1. Okay, so we have gotten my modulus. So the next one is the argument. So tan inverse, sorry, argument of z is simply theta, which is what? The tan inverse of the absolute value of what? Y over x. Okay, which is what? Tan inverse of the absolute value of my y is 1, while my x is 0. So which is what? The tan inverse of 0. And tan inverse of 0 is what? 90 degrees. Okay, tan inverse of 0 is 90 degrees because tan 90, is it 90? Sorry, 0. No, tan 90 is undefined. Tan 0 is 0. So tan inverse of 0 is still 0 because tan 0 is 0. Or use your calculator and check it. Tan inverse of 0. Are we having 0 at the denominator? Sorry, if I'm having 0 divided by denominator is undefined. When 0 is at the denominator is undefined, please. Undefined. And tan 90 is undefined, so the answer is 90 degrees. Because tan 90 is undefined, so the tan inverse of undefined is 90 degrees. So let's go to the next one. So I've got C. So D said that Z is equal to minus 4. In fact, minus 4 plus 0i, because you must get, there is no I here, that's why I added 0i. So therefore my x is minus 4 and my y is what? My y is 0. So that is that. So I'm going to have that that my modulus is simply the square root of x squared plus y squared, which is what? The square root of minus 4 all squared plus 0 squared, okay? Which is the square root of 16, which is what? 4. Okay, I've gotten that my modulus is 4. Now, if my modulus is 4, my argument of z is simply theta, which is what? The tan inverse of absolute value of y over x. Okay, but before that, we need to draw it. So, in the drawing of this one, my x is now negative. So, draw line on the negative x. Then y is 0. Y is 0 means on this line. So it can either be positive or negative. So my answer will fall within here or here. Okay, so that is that. In fact, my answer falls on this line. My answer falls on this line. So let us get something. So I'm having that what? That my theta is simply tan inverse of what do we have now? This is my x is minus 4 over my y is 0 up 0 over what? Minus 4. So what do we have? So an absolute value means that the negative will go. So this is what? This is even tan inverse of the negative will go. So 0 divided by 4 will give you just 0. And tan inverse of 0 is 0 because tan inverse of 0 is what? 0 because tan 0 is still 0. But my x is negative. My x is negative. So since my x is negative, it's going to fall. It's going to fall within 270. Okay, it's going to fall within 270. In fact, 180 or 360. 180 or 360, or even 270. So you can check it. 270, 180, 360. So check anyone that can give you 0, and then that is the answer. Just check tan this is 0, tan this is 0, tan this is 0, tan this is 0. So let us just check it. Tan 270. Okay, tan 180. So not in radian. Tan 270, tan tan 180, tan 360. You can use your calculator and check. I don't understand what this my calculator is doing. Once you get tan, it will automatically enter in radian. They don't want it to be in radian, they want it to be in degree. So this is tan. Okay. Aha, yes, it's now in degree. Thank God, I've seen it. So tan 360 is 0, then tan 2/7. Okay, it doesn't work. So tan, in fact, we don't even use 2/7. So it's either 180. We don't use 2/7. So the answer falls within 180, 180 or 360. Yeah, 180 or 360, because we don't use 270. So, and since it falls at this side, it could be either in the fourth quadrant, within fourth quadrant and the third quadrant, on that range. So, but I think the answer should be 360, because the 180 is on this straight line. So the 180 is on the, in fact it's 180, but tan 360 is still 0. So I think it's 180 degrees, just the 180 plus 0, so which is 180 degrees. That is that. So the next one, the ABCDE. Now E said that Z is equal to 1 minus I, which means my X is 1 and my Y is minus 1. So you have to draw it again. Plus Y minus Y plus X minus X. So our X is plus, draw line on the side of plus. My Y is minus, draw line on this minus. So they are meeting. Where are they meeting? They are meeting at the fourth quadrant. So the other one is 180, don't forget to. They are meeting at the fourth quadrant. Because this one was in the left hand side. So it is either on the 180 degrees, on the third or second quadrant, but it cannot be the second quadrant. So it is 180 degrees, okay? But had it been it fell here, then it will now be 360 degrees. So this one now, we now have that my Z modulus is now what? The square root of x squared plus y squared, which is what? The square root of 1 squared plus 1 squared, which is the square root of what? 2. That's all. Then my argument of Z is simply theta, which is what? The tan inverse of the absolute value of what? Y over x, which is what? Tan inverse of what? Minus 1 over 1, okay, which is what? Tan inverse of 1, okay, because we are using absolute value. Absolute value means we don't need the minus. So 1 divided by 1 is 1, and tan 45 is 1, so it's going to give me 45 degrees. But this thing fell in the fourth quadrant. Since it fell in the fourth quadrant, my theta should not be what? 360 minus that 45 degrees, so that my answer will be in the fourth quadrant, okay? So I'm going to have that the answer is now, so that's why you need to draw it, so that you know where your answer will fall. 360 minus 45, so I'm having 350, so this is 315 degrees, okay? So that is for E. And then finally for F, for my F, I have that what? Z is equal to root 3 minus I. So my X is root 3 and my Y is what? Minus 1. So you are going to draw it again to see that this is negative Y. So draw line on the negative Y. Positive X, draw line on the positive X. They equally met at the fourth quadrant again, because this is first, second, third, and the fourth quadrant. So they met at the fourth quadrant. But I know that my absolute value of Z, which is what? The modulus of Z, which is x squared plus y squared, which is what? The square root of root 3 all squared plus minus 1 all squared. So which is what? The square root of 4, which is 2. Okay? Square root of 4, which is 2. Because this is 3. Square cancel square root 3. 1 squared is 1. So 3 plus 1, 4. Square root of 4, which is 2. So the argument of Z is simply theta, which is what? The tan inverse of the absolute value of y over x. Okay? So I'm having what? I'm having that theta is equal to what? The tan inverse of absolute value of minus 1 over what? Root 3. So we don't need the minus. So I'm having what? Theta is equal to what? The tan inverse of what? 1 over root 3. And tan 30 will give you 1 over root 3. So therefore, tan inverse of 1 over root 3 is what? 30 degrees. But 30 degrees is in the first quadrant. So to take it to the fourth quadrant shows that the argument of z, which is theta, should now be what? 360 minus 30, which is what? 330 degrees. So that is that for this particular one. So let's get to the next question. So let's get to the next question. Okay. Let me check my time. So let's be fast. So let's get to the next question. And the next question said, they said prove the following by okay, I think I'm going to do this one in the next video because of my phone. Okay, yeah, we are back. All right, so okay, let's continue. This one said that we should prove by the Moivre theorem. Okay, we should prove it by the Moivre theorem, and then it says that number A said that cos 4 theta is equal to 8 cos 4 theta minus 8 cos squared theta plus 1. Okay. Okay. What do we do here? We know that okay. What do we do here? Okay, we know that z is equal to what? R in bracket of what? Cos theta plus what? I sine theta. Don't forget this. Is it not? This is when it is in polar form. Then z raised to power n is equal to what? R cos theta plus what? I sine theta. Then all raised to power what? All raised to power what? N. Okay, and then which means z raised to power 4 is equal to what? R in bracket of what? Cos theta plus what? I sine theta. Then everything is raised to power what? 4. So the Moivre said that is z raised to power 4 will now be R raised to power 4, then in bracket of what? Cos 4 theta. The 4 will come and multiply this 4 theta plus I sine 4 theta. Okay, that is what he said. So this thing should be equal to what? R raised to power n cos n theta plus I sine n theta. Okay, that's what he said. But let us expand this. Now I want to equate something. I want to equate this side and this side. I have that this is what? This is same as say R raised to power 4 cos theta plus I sine theta all raised to power 4. Okay, if I share the 4 for both of them, and the Moivre said that is equal to R raised to power 4 cos 4 theta plus I sine 4 theta. Okay, now this will take care of this. So let me expand this by binomial. What did binomial said? If you go to my video on binomial expansion using Pascal's triangle, if I use Pascal's triangle, I'm having one. The other one for 3 is 1 3 3 1. I don't forget this one. So this plus this is 4. This plus this is 6. this is 4 1 1. Okay, so for 4 is 1 4 6 4 1. Please go and watch my video on binomial expansion. So to expand, I want to expand the left hand side, which is, let me use binomial 1 4 6 4 1. These are the coefficients. So I have the first one 1, then the first one, which is cos theta, will be raised to power 4, and then the second one I sine theta will start from 0 plus, okay, look at how it goes, that x plus y all raised to power 4. I'm going to use the coefficient 1 4 6 4 1. So it's going to be what? 1, take the first one, x will be raised to power 4, and the second one will be raised to power 0, plus the next one 4. This one will now be raised to power 3, okay, so that the other one will be raised to power 1. Okay, that's how you'll be giving him 1 1 until you are done. So that is what we want to do here. Plus the other one is what? 4. So this one now, which is cos theta, will now be raised to power what? 3. Why I sine theta, okay, will be raised to power what? 0. 1. Okay, so let's continue. Plus the next one is what? 6. And then 6. The next one, with this one, cos theta, will now be raised to power 2. Why I sine theta will be raised to power what? Will still be raised to power 2. Okay, plus the next one is what? 4. And then in that 4, I'm having that what? Cos theta will now be raised to power 1. Y sine theta will still be raised to power 3. Then the last one is now what? Where we have 1, and the cos theta will now be raised to power what? 0, and I sine theta will now be raised to power what? 4. Okay, so if I do that, I'm going to have anything raised to power 0 is 1. I'm expanding this, so I'm expanding this. Anything raised to power 0 is 1. Okay, don't forget that all these things I wrote is equal to cos 4 theta plus I sine 4 theta. This my board is too small. Okay, I want to write it very long like this so that you will understand what I'm saying. But okay, let me just continue. So this is what? Let's do this. This is cos 4 theta as power. Anything raised to power 0 is gone. Now, if you look at this, the cos is the real part. The cos is the real part, and the one that they say we should prove that this is equal to this, they are talking about the real part. So let me bring out all the real parts. Anyone that will give me I'm not interested in it. This is raised to power this, and the I has gone, so I'm interested in this one. Now this is raised to power 1, I is still there. I'm not interested in this person because I is still there. Okay, I squared is minus 1, so I'm interested in this one. I squared is minus 1, so I'm interested in plus 6. In fact, it's going to be minus because I squared is minus, so minus times plus is minus. So minus 6 cos square theta sine square theta. So that is for these two. Now here, don't forget that here I'm having I here. Now I raised to power 3, I will still be there, so I'm not interested in this one. Okay, so I'm interested in the last one. Plus anything raised to power 0 is 1. I raised to power 4, I raised to power 4 is equal to what? Even number. I'm expecting 1 or minus 1 divided by 2 is equal to R is equal to 1. So I'm having plus 1. So what is remaining here is what? Sine 4 theta. Okay, sine 4 theta. So now having this, what do we do now? What do we do? We want to get this. This is what we want to get. How do we get this now? Okay, so let me factorize here and see what I'm going to get. If I factorize here, I'm going to get a cos 4 theta minus what? They have sine square theta in common. Minus sine square theta. Minus sine square theta they have in common. So what is remaining here is what? Cos square theta plus what? Sine square theta. Okay? And cos square theta plus sine square theta is equal to 1. Don't forget. Cos square theta plus sine square theta is equal to 1. Okay, sorry. I brought out minus. So minus will make here. Sorry, here will be minus because minus times this will give you this, and minus will give you plus, so that this time this will give you this. Okay, so and trigonometry say that, but But trigonometry say that cos square theta minus sine square theta is equal to cos 2 theta. Okay? Anything you are doing, be looking at if, be checking what you are going to get to, so that you will not make mistake. Okay, there's nothing like 2 theta there, so I'm not going to use this law. Okay, but trigonometry said again that sine square theta is equal to what? 1 minus cos square theta. And that is what I want to use. So anyway I see sine square theta, I want to put 1 minus cos square theta. So I'm having cos 4 theta minus, instead of putting this, I'm going to say in bracket of 1 minus cos square theta in bracket of, then this one is what? Cos square theta minus in bracket of, this one is what? 1 minus cos square theta. So you close again. So now let me open. So I'm going to have cos 4 theta, okay, minus in bracket of 1 minus cos square theta in bracket of, here is going to give me cos square theta, this time this, minus 1, this time this, minus 2 cos square theta. Okay, so permit me to clean here. So I'm going to have cos 4 theta minus in bracket of 1 minus cos square theta, then in bracket of, now how did I get to this time? This is not too solid. This time this is this time so this minus this is gone. Minus this time this is this, minus this time this is plus. This plus this will give me 2 cos square theta, okay, minus 1. So let me open the bracket. I'm having cos square theta minus in bracket of, this time this will give you 2 cos square theta, this time this will give you minus 1, minus this time this will give you minus what about the 6? I think there is a mistake somewhere. The 6 is where the mistake is. Okay, permit me to start afresh, please. Permit me to start afresh because of my board. Okay, let me start afresh. We want to get this. We know that according to the Moivre theorem, that z raised to power n, okay, normally that z is equal to what? R bracket what? Cos theta plus what? I sine theta. Okay, that's my R. Then let me check my time. Okay, so I'm having that what? Then z raised to power n, they say that is equal to what? Z x raised to power n in bracket, r raised to power n in bracket of what? Cos theta plus I sine theta, all raised to power n. And he said that z raised to power n is equal to what? R raised to power n in bracket of cos n theta plus I sine n theta. Okay, that's what he told us. So let me now change it to 4. So which means that z raised to power 4 is set as what? R raised to power 4 cos theta plus I sine theta. Okay, like this, all raised to power 4 again, which the Moivre said that is R raised to power 4 cos 4 theta plus what? I sine 4 theta. That is what he said, that it can just multiply. So that is what he said. Now this can take care of this, so I am left with these two men. That is what I want to work with now. Permit me to clean here so that I can now be writing it. Okay, or let me just be writing it, then when I'm done I want to clear here by Pascal's triangle, which is 1 4 6 4 1. Okay, like I did before. So let's take it gradually. 1, so you say 1, then take the first one, which is cos theta raised to power 4, then the other one I sine theta. We start from 0 plus, then take the next one, 4 cos theta will now be raised to power 3, and then I sine theta will be raised to power what? 1 plus the next one is 6, then you have what? Cos theta will now be raised to power 2, and I sine theta will now be raised to power what? 2 again. So the next one is what? Plus 4. Then you now have what? Cos theta. All raised to power what? 1 now, because it's 1. Then the other one will now be I sine theta will now be raised to power what? 3. Then the last one plus the last one is now 1. 1 in bracket of cos theta will now be raised to power 0. Why I sine theta will now be raised to power what? 4. Okay, so that is how it is now. And don't forget that it is equal to this man, which is cos theta plus cos 4 theta plus what? I sine 4 theta. So now if you look at where we are interested in, we are interested in the real part. This is the real part. We are not interested in the imaginary part. So anything that will give us imaginary, we are not interested in it. So let's go now. Imaginary here, I is raised to power 0, is gone. So this one is the real part. So I'm bringing it out. Cos what? 4 theta. You know that this thing and this thing are the same thing. Cos 4 theta. Now, I raised to power 1 is I. So I will be here. I'm not interested in this person. Now, I squared is minus 1. So the I will disappear here. I'm interested in this one. So I squared is minus 1 times this, which will give you minus 6 cos square theta. Okay? Then sine square theta. So the next one, I raised to power 3 is minus I. I'm not interested in this one. It's going to have I. Then I'm interested in the last one because I raised to power 4 is 1. So this one is gone. Anything raised to power 0 is gone. So what is remaining here is just sine 4 theta. Then is equal to what? Cos 4 theta. So I just took out all the real parts now. So I want to work on this place. This is my main job. This is my main job. So permit me to clean up here so that I can get my main job. So my main job is now to say that what? Let me write this first. That cos 4 theta is equal to what? Cos 4 theta minus 6 cos square theta sine square theta plus sine 4 theta. So that is that. Now, but in their own, there is nothing like sine there. So let us now work with cos alone. Okay, but before that, I know that cos 4 theta minus 6 sine square theta, okay, in bracket of, in fact you can factorize, or if you don't want to factorize, look at what I want to do now. 6 cos square theta sine square theta plus sine square theta all raised to power 2. This one will give me this. Why did I get this like this? Is because I know that sine square theta is written as 1 minus cos square theta, okay, according to trigonometry. So anyway, I see sine square theta, I'm going to put this. So let me bring this one down. Cos 4 theta is equal to what? Cos 4 theta like this, raised to power 4 minus 6 cos square theta in bracket of, instead of writing this, I'll write 1 minus cos square theta, okay, plus this one is again 1 minus cos square theta all squared. So let us open the bracket. I'm having cos 4 theta is equal to cos 4 theta like this minus minus 6 times this will give you what? Minus 6 cos square theta. Minus minus is what? Plus. This time this will give you what? 6 cos 4 theta. So I'm done opening this bracket. This one times 1 is still this one. This one times this will give you this one. So let's open this bracket. And this bracket said this times itself, which is square the first one, 1. Multiply the first one and the second one, double it. Minus 2 cos square theta. Then square the last one, have plus cos 4 theta. So that is what it gave me. So now let me bring out, this is cos 4 theta like this. So this is 1. 1 plus 1, 2. 2 plus 6 is 8. So I'm having 8 cos 4 theta like this. So the other one now, minus 6 minus 2 will give you minus 8. So I'm having minus 8 cos 2 theta. Then I'm left with plus 1. You see, this is the same thing as this. So we have proved it by the Moivre theorem. Okay, we have proved it by the Moivre theorem. So let's go to the next one. I hope it's not too long. Water. So if you practice it like 3-4 times, watch the video like 5 times, you can get it. Okay, so let's go to the next one. The next one is okay, B. The B part said that we should prove sine 4 theta to be equal to 4 cos 3 theta sine theta minus 4 cos theta sine 3 theta by the same Moivre theorem. Okay, it's the same thing we did before. We know that z raised to power n is equal to r raised to power n cos theta plus I sine theta all raised to power n, which he said that is equal to r raised to power n cos 4. Sorry. Okay, let me use 4 straight. 4. So 4. So here will be 4 theta plus I sine 4 theta. Now, the sine theta is for the imaginary part. So we are going to be interested in the imaginary part in this one now. So let us go there. This will take care of this. So let us expand this one by the same Pascal's triangle. Don't forget 1, 4, 4, 1. So let's do the same thing again. 1 cos raised to power 4 and I sine theta raised to power what? 0 plus the next one 4 in bracket of what? Cos theta will now be raised to power 3 and I sine theta will now be raised to power what? 1. Okay, plus the next one is what? 6. Okay, 6 is supposed to be here. 6. Then cos theta will now be raised to power 2 while I sine theta will now be raised to power 2. Okay, plus the next one 4 cos theta will be raised to power what? 1 while I sine theta will now be raised to power 3 plus the last one, which is 1 cos theta is because of that water. So cos theta will now be raised to power 0 while I sine theta will now be raised to power 4. So don't forget that, and don't forget is equal to what? Is equal to cos 4 theta plus I sine 4 theta. So don't forget that we are interested in only the imaginary part now. This is anywhere I is. I will not be here. We are not interested here. I will be here. We are interested here. We are interested in 4 cos theta all raised to power 3 in bracket of I sine theta all raised to power 1. We are interested in this one. Okay, let me just write it straight. Don't know why I just soaked this thing. Let me just write it straight. Okay, so this raised to power this will give you 4 cos 3 theta, then I sine theta. Or let me bring the I at the back. It's the same thing. That is 4I, then cos 3 theta, then sine theta. Now we are not interested here because I squared is 1. We are not interested here because it does not have I, but I'm interested here. I raised to power 3 is equal to I raised to power 3. I'm expecting I or minus I. So if you divide it, 3 divided by 2 give you 1.5. So which is minus I. So it's minus I. So the minus I will now be minus 4I cos theta. Then what? Sine 3 theta. Is it not? Is equal to, I'm not interested here because I will disappear here. Is equal to what? The imaginary part, which is what? I sine 4 theta. So if you look at this now, they have I in common. If you bring out the I they have in common, I'm going to have 4 cos 3 theta sine theta, okay, minus 4 cos theta sine 3 theta. is equal to what? I sine 4 theta. So I will take care of I. So therefore, you see that, therefore sine 4 theta is simply 4 cos 3 theta sine theta minus 4 cos theta sine 3 theta. Proved. This is the same thing as this. Proved. Okay? So you see, this one is very, very simple. He doesn't want you to go further. Okay? So this one is very, very simple. So let's move to C. It was that first one that looks complicated because of you have to do some trigonometric ratios. So then for C, now C is now raised to power 3. C is now raised to power 3, and it's very simple. Okay, so look at C. They say we should prove that cos 3 theta is equal to what? Cos 3 theta minus 3 cos theta sine square theta. This one is very, very simple. By De Moivre, we know that what? Z raised to power 3 is equal to what? R raised to power 3 cos theta plus I sine theta, then everybody raised to power 3, which he said is the same as R raised to power 3 cos 3 theta plus I sine 3 theta. Okay, so let us expand this thing by Pascal's triangle, and for 3 is 1 3 3 1. Okay, so go and watch my video on Pascal's triangle. So this has already cancelled this. So to expand this man, 1, then you now put what? Cos theta will now be raised to power 3, while I sine theta will be raised to power 0, plus the next one is 3 cos theta will be raised to power what? 2, while I sine theta will now be raised to power 1, plus the next one 3 cos theta will now be raised to power 1, while I sine theta will now be raised to power what? 2. Okay, then finally plus the last one 1, and then cos theta will now be raised to power 0, while I sine theta will now be raised to power 3. Don't forget it's equal to what? Cos 3 theta plus I sine 3 theta. Now, this one is cos, so we are interested in the what? The real part. Anything raised to power 0 is gone. So this one does not have I, so I'm interested here. Cos 3 theta like this. This one has I, I'm not interested here. This one does not have I because I squared is minus 1. So minus 1 times this is what? Minus 3 cos theta, then what? Sine square theta. Okay? This one we have I, so I'm not interested. And it's equal to what? Cos 3 theta. So if you look at that, arrange it very well. That cos 3 theta is equal to what? Cos 3 theta like this. Minus 3 cos theta sine square theta. So this is the same thing as this. Proved. Okay, so we are done with that question. So let's go to the next one. Okay, so let's go to the next one. All right, so let's move. We are done with question number 7. Oh, he said question number 6. And question number 6 said, I didn't even know, that Z raised to power 8, that if, okay, that we should find Z raised to power S. Find Z raised to power 8 if Z is equal to 3 plus 2i. Oh, this is very simple. So by the Moivre theorem, we need to get our Z in a polar form. Okay, so getting Z in polar form, we have that that our R is equal to what? The square root of x squared plus y squared, which is equal to the square root of 3 squared plus what? 2 squared, which is what? The square root of what? 9 plus 4, which is the square root of 13. So I've gotten my R. So the next thing I need to get is my argument of Z, which is theta, which is equal to what? the tan inverse of the absolute value of y over x, which is theta, is what? The tan inverse of the absolute value, my y, x, and y. My y is 2, my this is 3. Okay, so let us get that. So tan inverse of 2 divided by 3. Okay. So I'm having tan inverse of 2 divided by 3. So I'm having 33. So theta is now 33.69. Okay, which let me approximate it to 34 degrees. That is my theta. So therefore, let me continue here. Therefore, my z is equal to r cos theta plus what? I sine theta. Okay, so which is what? My z is what? Root 13. Then in bracket of what? Cos my theta is what? 34 plus what? I sine 34. Okay, so now z raised to power 3, raised to power 8, sorry, is equal to what? Root 13 in bracket of what? Cos 34 plus I sine 34. Everything raised to power 8. So which is what? Root 13 raised to power 8, then cos 8 times 34 plus I sine 8 times 34. So I'm going to have that this is 13 raised to power 4, because the 2 will divide this to give you 4. So 13 times 13 times 13 times 13 times 13. So this is what? Just 13 raised to power 4. Okay, we now have cos 8 times 13, 8 times 13. I'm having 104 plus I sine 104. So that is that. Okay, so that's just the answer for question number 6. So I did question number 7, and so question number 8. Question number 8. Question number 8 said that if z is equal to cos theta plus I sine theta, okay, then use the Moivre's theorem to show that a z plus 1 over z is equal to 2 cos theta. Okay, let's show that solution. Now, we know that z is equal to what? Cos theta. Okay, now watch. Z plus 1 over z. Okay, let me just get what is z and get what is 1 over z. Okay, z raised to power z 1 over z is same as say z raised to power minus 1, which is what? Okay, which is what? Which is cos theta. Okay, in fact, cos minus theta. Cos minus theta, okay, plus I sine minus theta. But cos is an even function, so it's going to be cos theta minus I sine theta. Okay, so just know that this is this, that 1 over z is equal to z raised to power minus 1, which is this. So since they gave us, we should find a, which is z plus 1 over z, which is, what is our z? They have given us, which is cos theta plus I sine theta. Then plus, they have given us this one, we got it as what? Cos theta minus I sine theta. So this and this is gone. So I'm left with this plus this, which is 2 cos theta. Proved. Very, very simple. Okay. Now B now said we should find z squared plus 1 over z squared. Okay. It's very, very simple. So our z squared, according to the Moivre, should be what? Cos 2 theta plus I sine 2 theta. So which means our z raised power minus 2, which is 1 over z squared, is sent as z raised power minus 2. So it's going to be cos 2 theta minus I sine 2 theta. So if you add both of them, it's going to be cos 2 theta plus I sine 2 theta plus cos 2 theta minus I sine 2 theta. So this and this is gone. So I'm left with 2 cos 2 theta. As simple as that. That's just the answer. So we have proved it. They say we should prove, that is B question. Look at B question. They say we should prove that z squared plus 1 over z squared is equal to 2 cos 2 theta. So we proved it. So the last but not the least, number C, said we should prove that z raised power n plus 1 over z raised power n is equal to what? 2 cos n theta. So it's the same thing. Okay? So we know that z raised power n should be what? Cos n theta plus what? I sine n theta. So z raised power minus n, which is this one, is sent as what? Cos n theta, okay, minus I sine n theta. So if you add both of them, which is zn plus 1 over zn, is going to be what? Cos n theta plus I sine n theta plus cos n theta minus I sine n theta. Okay, so this and this is gone. So I'm left with 2 cos n theta. Proved. So we are done with that. I don't know why I am still soaking this thing unknowingly, and it will not allow me to write something very well. Okay, let's manage. So the next question, that is question number we have done 5, 6, 7. Okay, so 10 and 12, and I think that's the last question. So question number 10. Question number 10 said, question number 10 said, in arranging people around a circular table, we take into account their seat relative to each other, not the actual position of any one person. Show that any person can be arranged around a circular table in n minus 1 ways. Okay, in around a circular table, where we have to make one person. Okay, let me have this. Okay, let me have this, a circular table. Okay, now we need to arrange one person. Don't know what is happening. We need to arrange one person. This is the first person, the second person, the third, the fourth, the fifth, for instance. Okay, now if you start changing them, you won't even know where you started and where you stopped. So but if you decide to keep just one person constant, then you will not be rotating the other person. Okay, you will not be doing what? Rotating the other person. So if you are rotating the other person, we are going to have that that is to say we are having n factorial all over what? All over n that they are. Okay, all over what? The n that they are. So if we do this, we are going to have that is what? N factorial is equal to saying n into n minus 1 factorial all over what? That n. So this take care of this. I'm left with n minus 1 factorial. So that is what I think. Okay, so you can make your research and get more answer on that. That is what number 10. So number 12. Number 12 said there are 20 people. There are 20 people who work in an office together. 4 of these people are selected at, please be writing the question, are selected at, okay, they said there are 20 people to work in an office. Okay, 4 of these people are selected to attend 4 different conferences. Okay, they say that the first conference, okay, so the first person selected, we we go to a conference at Abuja. So the first one is Abuja. This is the first box where the first person will enter, Abuja. Okay, then the second place is where? The second place is at Lagos. Lagos. This is for Lagos, conference in Lagos. So the next one is Enugu. Enugu. This is for Enugu. And then the last one is Imo. The last one is Imo, and this is for Imo. So now, out of 10 people that are to be selected here, so to select one single person that will go to Abuja, I can select out of the 10 of them. Okay, so that is out of the 10 of them. Now, once I've selected one person here, one person is already gone, so I'm left with 9 people. So to select for the second people that will go to Abuja, I have out of 9 people to select. Then another one person is gone, I'm left with 8 people to select. Another one person is gone, I'm left with 7 people to select. So this is my answer. Okay, this is just my answer. Or just say 10 permutation 4, which is what? 10 factorial all over 10 minus 6 all factorial, which is what? 10 factorial over what? 4 factorial, which is what? 10 times 9 times 8 times 7 times 6 factorial. Sorry, this is 4, and this minus this is 6. Okay, all over 6 factorial. So this take care of this. I'm still left with the same answer: 10 times 9 times 8 times 7. So do that, and then that is just the answer. So the next one, and which I think is the last one, is question number 15. Question number 15 said, how many ways can one select a chairman and co-chairmen of a committee if you have 10 people to choose? You have 10 people to choose. Okay, so since you have 10 people to choose, and you want to select a chairman and co-chairman, okay, in selecting a chairman, you have 10 out of that 10 people. So select just one person out of that 10 people to become a chairman. Then it's meaning 9. So to select, you have 9. That's all. 10 times 9, which is what? 90. As simple as that. So thank you very much for watching. You can drop your own opinion. What your contribution is allowed as well. Okay, so please don't copy. Try to master it, learn it very well, and the peace of the Lord will be with you. God bless you.